Assalamualaikum. So we are from group 3. My name is Ifa Awni binti Sakaria.
My name is Nur Afika binti Shahrum.
And my name is Mariam Jamila binti Muhammad Saifuddin.
Okay, so I am going to explain on how we solve this question. First, we need to find the equation of the initial temperature line from the graph so that we can confirm the initial condition IC for the boundary value problem. To do this, we will calculate the slope m of the line between point 0, and 0.500. We get m value equal to 200, then we use the point slope form. Y minus 0 equal to 200, x minus 0. So, y equal to 200x. This means the temperature increases from 0 to 100 between x equal to 0 and x equal to 0.5. Then stays constant at 100 from x equal to 0.5 to x equal to 1 based on the graph. So next, based on the questions, the PDE already given, which are u sub t xt equal to 25 u sub x. The ends of the rod are kept at fixed temperature, which left equal to 0 and right equal to 100. This gives us the boundary condition BC, U0t equal to 0 and U1t equal to 100. At time t equal to 0, the rod is not evenly heated. So, based on the graph, we can see that the temperature starts at 0 degrees Celsius and increases to 100 degrees Celsius at the halfway point x equal to 0.5 and then stays at 100 degrees Celsius all the way to the end of the rod. So this means the initial temperature is a piecewise function. 0 u at 0 equal to 200x and 100. We use the piecewise function to describe the rod's starting temperature, then combine it with the heat equation and fix end conditions to form the full BVP problem. Okay, so for question 2, identify the type of PDE for u sub xx plus 6u sub xy plus 9u sub yy equal to 0. We are given general form as shown, so we just need to compare from the question and the general form. Here we have AU sub XX equal to U sub XX from the question. Thus, A equal to 1. And second, we have BU sub XY which equal to 6U sub XY. And then, the value of B equal to 6. And last one, we have CU sub YY equal to 9U sub YY. Thus, C equal to 9. Then, we use B squared minus 4AC and we substitute the value of A, B, and C into the equation B squared minus 4AC and then we will get 0. Thus, the PDE is parabolic because B squared minus 4AC is equal to 0.
So now I will present about question 3. So our question 3, the boundary condition is both Newman, which is x prime 0 equal to 0 and x prime 1 equal to 0. And our initial condition has 3, which is 0, -1 and 0. And so for the solution, we let our uxt equal to xx dt and utxt equal to xt t prime t and usx xt equal to x double prime x dt. And after that, we substitute that into PDE, which is utxt equal to usx xt and x, and which is a xxt prime t equal to x double prime x dt. After that, we solve the PDE using separation of variable, which is equal to x double prime s divided by xs equal with t prime t equal by tt, which is equal to negative lambda. And by that, we get two ordinary differential equation ODE, which is x double prime s my plus lambda xs equal to 0 and t prime t plus lambda tt equal to 0. So next step is we should solve for variable xs. So there is three cases. So first, for case 1, we assume lambda equal to 0 and we substitute lambda 0 into our lambda 0 in our equation in x. So we got x double prime s equal to 0, and we to get xs, we integrate x double prime to get x prime, and then we integrate x prime to get xs, which is we get c1s plus c2. After that, we apply BC, which is our boundary condition, and that is 2 x prime 0 equal to 0 and x prime 1 equal to 0, and then we apply in our x. So in x prime 0 equal to 0, we got a new xs equal to c2, and after that we apply another BC, which is x prime 1 equal to 0, which is we get our new xs is c2, which is non-trivial solution. So next, for our case 2, our lambda is equal to negative beta power of 2 less than 0. And after that, we substitute our value of lambda in our x equation, as we get x double prime s minus beta power of 2 xs equal to 0. And we got m power of 2 minus beta power of 2 equal to 0, and we simplify it, we got m equal to beta, which is distant root hyperbolic function. After that, we got our xs is c3 cos beta x plus c4 sin beta x. And then same with the case 1, we apply our boundary condition. So first boundary condition is x prime 0 equal to 0, and then we got our new xs is c3 cos beta x. And next, our another boundary condition is x prime 1 equal to 0, and then our new xs is 0, which leads us to trivial solution. So for the last one, we solve for case 3. So for lambda in case 3, we got beta power of 2 greater than 0, and we substitute the value of lambda in our x equation. We got x double prime s plus beta power of 2 xs equal to 0, and then we got m power of 2 plus beta power of 2 equal to 0, and we simplify it, we got m equal to plus minus beta, which leads us to complex root trigonometry function. So our xs is c5 cos beta s plus c6 sin beta x. And same with step in case 1, case 2, we apply our boundary condition. So for our first boundary condition, x prime 0 equal to 0, and then with that we got our new xs is c5 cos beta x, and then for our other boundary condition is x prime 1 equal to 0. And after that, we got x prime 1 equal to negative beta c5 sin beta. So to obtain a non-trivial solution, we let sin beta equal to 0. So we got beta equal to n pi and negative beta c5 not equal to 0 to get a non-trivial solution. With that, we can conclude that our new x for case 3 is C5 cos n pi x for n equal to 1, 2, 3, 4, and infinity.
So next I will present on how to solve tt. So this is the equation for solving the tt, which is t prime t plus lambda tt equal to 0. So as usual, we use 3 cases for this solution. So for the first case, the lambda is equal to 0. So we will obtain the solution, which is k1. And then for solution for case 1, uxt equal to c2 k1, and we will replace it by a naught. Okay, next is case 2. For case 2, we use lambda equal to negative beta squared. So by this lambda, we will obtain one root exponential functions, which is m equal to beta squared. And the function will be will be tt equal to k2 exponential the power of beta squared t. And then for the solution for case 2, uxt equal to 0 multiplied by k2 e beta squared t. And for the solution, we will obtain 0. Okay, next, for case 3, we will use lambda equal to beta squared. As we know from previous, in solving xx, we obtain that the value of beta is n pi. So we will substitute n pi into beta squared, and we will obtain n squared pi squared. Then we will solve the formula, and we will get one root exponential function. So the value of m is equal to negative n squared pi squared. And then we will obtain the value of tt equal to k2 exponential the power of negative n squared pi squared t. And then we will get the solution for case 3, which is uxt equal to c5 cos n pi x multiplied by k2e negative n squared pi squared t. And then the solution will be convert into summation of n equal to 1 infinity an cos n pi x e negative n squared pi squared t. Next, after finding tt for case 1, case 2, and case 3, we need to find the general solution, which is uxt equal to case 1 plus case 2 plus case 3. So in this case, the answer will be a naught plus summation of n equal to 1 infinity an cos n pi x exponential the power of negative n squared pi squared t. Okay, next we will apply initial condition. The initial condition for this problem is u at 0 equal to 0. Then we will compare the initial condition with the general solution. So we will obtain u at 0 equal to a naught plus summation of n equal to 1 infinity an cos n pi x. Exponential will be 1 because t is 0. Next, we will apply half-range Fourier cosine series. The formula of half-range Fourier cosine series is fs equal to a naught over 2 plus summation of n equal to 1 infinity an cos n pi x over L. So we need to find a naught and an. So to find a naught, the formula will be using 2 over L integrate 0 until L fx dx. To find coefficient an, we will use formula 2 over L integrate 0 until L fx cos and pi x over L dx. Next, for this slide, we will find coefficient a naught. So from the formula that we had discussed before, we need to substitute all the function for this question into the formula, which is the function for this question is 0, -1, and 0. So after substitute all three functions, we will get the answer -1 over 2. And then we need to find coefficient an. So same as a naught, we also substitute all three functions, which is 0, -1, and 0 into the formula. And then we will obtain the answer, which is an equal to -2 sine 3 pi n over 4 minus sine pi n over 4 over pi n. Therefore, finally, we can obtain particular solution from the general solution that we had find, which is the particular solution for our problem is u x t equal to -1 over 2 plus summation of n equal to 1 infinity minus 2 sine 3 n pi over 4 minus sine n pi over 4 over n pi cos 2 n x exponential the power of -n squared pi squared t.